Alrighty, we have two quadrilaterals here that are congruent, and we could describe if the two triangles are not triangles, quadrilaterals are congruent. It means we could pick this one up and set it on top of this one, or pick this one up and set it on top of this one, and they would match up perfectly. And the way to do that would be to move this one over to this one, or this one over to this one, would be to use a vector translation. We're just going to describe what those vector translations would be. So, to take A, B, C, D to E, F, G, H. And by the way, it's important how you name these shapes. So, see how the way they match up, A matches with E, B with F, C with G, and D with H. And they have to be, those pairs have to be in each name in the same order. So if A is first, then E needs to be first. And if B is next, then F needs to be next. Now, you don't have to name them in any particular order as long as they're named in the same order. So for example, I could call this one D, A, B, C, and this one down here H, E, F, G. Or I could call this one C, B, A, D, and this one would be G, F, E, H. So as long as they get named in the same order. So from here to here, we have to go down 1, 2, 3, 4, 5, 6, and left 1, 2, 3. So the vector would be -6. Oh wait, what am I doing? -3, -6. So the first part of the vector is your left-right movement, your change in x. The next part of the vector is your up-down movement, your change in y. And that should be the same for every point, by the way. So for A, it'd be 1, 2, 3, 4, 5, 6 down, and 1, 2, 3 to the left. And for C, it's 1, 2, 3 to the left, 1, 2, 3, 4, 5, 6 down. Okay. We could also go in the other direction. We could go E, F, G, H to A, B, C, D. In which case I'd be going, say, from F, would be forward, 1, 2, 3, and then up, 1, 2, 3, 4, 5, 6. So that would be 3, 6. Okay. And it would be the same for any other point here. H would go 1, 2, 3, 1, 2, 3, 4, 5, 6. 3 to the left, 6 up. All the points, 3 to the left, 6 up. Notice that these two vectors are opposites, kind of like, right? But which makes sense. I'd go forward 3 and up 6 to go in this direction. So the opposite of that would be to go back 3 and down 6. Also, although we've looked at the corners because they're easy points to kind of fix on, this same translation applies to every point on the shape. So even say, for example, this side point right here and that side point right there, 1, 2, 3, 1, 2, 3, 4, 5, 6. Or maybe even like a point that's part way, right? 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay. So, and that is describing the vector translation that maps one shape onto the other, or the other way around, the other shape back to the first.